Hi everyone, hope you are doing good today. I'm going to continue section 5.2 which is about events. So let's see what is this event mean. First, sample space and events. Sample space mean collection of all possible outcomes in our experiment. For an example, if I flip a coin, what are the all possible outcomes? There are only two possible outcomes, head and tail, right? Head and tail. So only possible outcomes are head or tail. So that's the sample space. When we talking about an event, event is a collection of outcomes for the experiment, which is in our experiment any subset of this sample space. So event is a subset of the sample space. Any event occurs if and only if the outcomes of the experiment is a member of the event. So if event exists, it should be in our sample space. So we denote these events by using capital English letters, so that we don't need to write that event, what is this event, again and again. Okay, this event is the third coin, third head occurs, something like that. We don't need to write it again and again. We just mention, okay, A equals third time head occurs. So after that, throughout the problem we can use A instead of using that sentence. Okay, that's why we use this kind of notation. Tossing a coin, sample space. Tossing a coin, as I mentioned, what is the sample space? So sample space is head or tail, right? Head or tail. This is the sample space. Tossing a coin just once. So event A, the side above is head. Okay, event A, which means this one, right? Head. Okay, the next example, tossing two coins. Oh, now we have to flip two coins. Okay, we have to flip two coins. What is the sample space? First I can get head, second I can get head as well. First I can get head, second I can get tail. What are the others? First I can get tail, second I can get head. First I can get tail, second I can get tail as well. So this is the sample space. All possible outcomes. All possible outcomes. Clear? Event B. This event we define at least one head. So under this example 5, at least one head. What are the outcomes? At least one head, which means two heads can be occurred, right? It's possible. So two heads also possible, at least one head. So in these cases, these pairs, we have at least one head. Can we consider tail tail? No, because there are no heads. Okay, at least one, no. So this event C, at least two head, at least two head, which means 3, 4, 5 heads are possible, but in our case we have maximum 2, right? So at least 2 heads, which mean this first one only. We cannot use this one or this one, right? Because we have only one head in this case. No heads. Okay, what are the no heads mean? There should be no heads, which mean simply this one only. Can we use head tail or tail head or tail head head? No, because it this set includes head. Okay, our case is no heads. Event E, one head and one tail. Okay, definitely should be a one head and one tail. One head and one tail, second one and third one, right? Can we use head head or tail tail? No, because it should be one head and one tail. Clear? Okay. Rolling a die. Rolling a die. Sample space. Okay, what is sample space? Rolling a die. So what are the values? 1, 2, 3, 4. Oh, sorry, 2 is not there. 4, 5, 6. These are the all possible values, right? So what is the sample space? 1, 2, 3, 4, 5, 6. Right? These are the all possible outcomes. Event F. And one more thing I forgot to mention you, when you define events, don't use same letter for another event. That means don't use a letter which you have used before. Clear? Otherwise we will confuse. You have mentioned, okay, A is event A is 2 heads, and again some lines later you use event A for 1 head. So don't use that. Okay, don't do that. Please use different letters for different events. Yeah. Okay, up face shows a prime number. Sorry, up face shows a prime number. So what are the prime numbers? Prime numbers are, first I'll write prime numbers. Prime numbers are numbers which can divide only by themselves, right? One and themselves. So prime numbers, first prime number definitely 1, then 3, 5, 7, 9 is included. No, 11, so on. Okay. So up face shows prime numbers. So how many prime numbers do we have in this case? We have only 1, 3, 5, right? See, 1, 3, 5. So up face shows prime numbers 1, 3, 5. This is the event. So please try to use this curly bracket, okay, to mention a subset or event or sample space. Please use this curly bracket. Okay, up face shows an even number. Even numbers, what are the even numbers? 1 is even number? No, 1 is an odd number, right? Even numbers 2, 4, 6, 8, so on. So we can get even numbers 2, 4 and 6. Odd numbers, what are the odd numbers? 1, 3, 5, 7, but 7 we cannot consider because we have only values from 1 to 6. Clear? Okay, example 7, considering 2 dice. Okay, that situation is really interesting. So I'm not going to do this one, rolling 2 dice. Please try to do this by yourself. Okay, it is very important. You can get help from 2 dice case what I discussed a few minutes ago. Okay, next one, Venn diagrams. These Venn diagrams are very old diagrams which we used in statistics, but still we use these Venn diagrams because it is really easy to represent probabilities and probability values. Okay, it's like a picture. By these Venn diagrams use shapes. Okay, but remember that all shapes are closed shapes. Okay, which means they should be like rectangles, sorry, they can be like rectangles, triangles, then can be circles, but they are closed. Okay, there are no opens. They should be closed shapes. Okay, so or you can use any other free shape, something like this, that's okay, but definitely should be a closed one. Okay, no holes. Okay, Venn diagram, this is the definition. Sample space is depicted by a rectangle, and the events are drawn as a disk inside the rectangle. That's the formal procedure, but if you want you can change that. That's no there is no restriction for that. It's just an simple definition for that. So this is my sample space. Sorry, it should be a closed one. Okay, sample space in general we denote by this huge rectangle. Okay, inside we can mention or we can draw our events. Okay, events drawn by circles. Okay, this gonna be event, let's say event A, this guy event B, this is my event C, this is my event D. So as I mentioned here, please try to name these events, okay, like by using this arrow or whatever. Okay, otherwise we don't know what is this event. I don't know what is this event if I mention it. This is event A. So these are events. All outcomes inside these events are inside these circles. Okay, this is how we draw the Venn diagrams. And please be noted this one, do not go outside this rectangle boundaries. Okay, everything within this sample space. Okay, we have relationships among these events. Does not occur, not this event, not this event, sorry, not this event means not this event mean E does not occur, not E, sorry, it's event, that event does not occur. Okay, something like that. Then A and B, event A and event B, which mean both A and B occurs. So A and B, remember this one, A and B. So both should be there. You have to consider both. Definitely you have to consider both. Okay, consider both. Okay, A or B, either A or B or both. So A or B mean consider A, B or AB together. Okay. Okay, this is the picture or pictures of Venn diagrams. See, this is an event within this rectangular boundary. So this is my sample space. Inside the sample space I have mentioned my event. My event is E. I need to mention the not T. Not T mean everything in the sample space without E. Okay, so that's how we colored them. You can just draw lines to color, no problem. You don't need to color like this. Complement of E, not E mean complement of E, all the outcomes but not E. Okay, A and B, this is my sample space, this is my A, this is my B. So both A and B should be there. So what is the area? This area, both A and B should be there. If you consider this area, only A has this area. If you consider this area, only B has this area. So this case A and B mean you have to consider both. Common in A and B, you have to consider common area belongs to A and B. Okay, third one, A or C. So A or C, you can consider area which belongs to A only, which means A, area which belongs to B only, this area, this area belongs to A only, this area belongs to B only, and also A and B, okay, which mean this area as well. So altogether A or B mean this huge area, okay, either A or B. So be careful with those words. Okay, let's try to do this example. I think I can cover those and B A sorry and O not by using this example. Okay, a non-profit organization will be selected from a group of 5 people. Okay, 5 people. Who are they? Emily, David, Victoria, Lily and Andrew. Possible outcomes can be represented as followed. Okay, sample space given, you don't need to think about that. Sample space given, how many? 1 2 3 4 5 6 7 8 9 10. So outcomes 10, right? There are 10 total outcomes. X define event that Victoria is selected. Okay, event that Victoria is selected, that event. So Victoria is selected, Victoria mean V. So which outcomes Victoria is included? This one, V, this one, Victoria, this one, this one, this one, and this one as well. So what are those? Here you don't have to count, okay, you just have to identify and write down what are the outcomes. EDV, EVL, EVA, DVL, DVA and VLA. Okay, so let's check the second one as well. Event that David and Emily are selected. So David and Emily, okay, David and Emily, which mean D and E should be there, both should be there, D and E. It doesn't matter about the it doesn't matter about the order, okay, it can be D and E or E and D, that it doesn't matter, okay. So DE or ED, okay, we have this one, DE, DE, okay, we have this one, DE, DE, we have this one, DE. Yeah, that's all, we have only these three, right? So EDV, EDL, EDA, only 3, right? ED, yes, yep. So C, event that fewer than 2 men are selected. Okay, 2 men, fewer than 2 men. Fewer than 2 men mean it can be 1 man, fewer than, so it cannot be 2 men, it can be no men or 1 man, that's it, okay. So you have to find the genders. Okay, Emily, I think it's women. So first I'll write down this one. Emily is let's say men, women, this W, David male, Victoria female, which means W. Okay, we will use male female, that's fine. F, this is F. So Lily F, Andrew M. So we have Andrew and David, they are the male, so both should not be there. A and D should not be there, okay, that's the goal. Fewer than 2, so M and D and A should not be in our outcome together, they can be in separately, okay, but together they cannot be in this outcome. So we have to pick them. First, the easiest way is pick uh, they are in together. Okay, A D O D A, A D O D A. Okay, here you have A D O D A, A D O D A, A D O D A. See, A D O D A. See, so we don't need them. See, even that fewer than men are selected. So in these three cases we have two men. Okay, so exclude them. Write down your um, space. What is that? What are they? EDV, EDL, and EVL, EVA, ELA. I need more room. ELA, yes, DVL, then VLA. So this is the event that fewer than two men are selected. Clear? So now you have to figure it out what is not X. You know what is X. Not X mean all possible outcomes except this X. Okay, all possible outcomes except S. Okay, let me write this one. Okay, not X. So you know what is X and you know what is sample space. Okay, so sample space minus your X. Actually it's not a numerical calculation, just think about like that. Sample space minus this X, that's the meaning of not X. So EDV we have in X, EVL, since I wrote it in sequential order. Okay, EDL, EDA, ED, so EDV, okay, EDL, EDA, EVL is there, then I can write EVA. Okay, EVA is also here, ELA is not there, then DVL is there, DVA is there, DLA is not there, right? So please check this one. This mention not A. Oh, sorry, not X, not A, X. Okay, not X, which mean all possible outcomes without X. Okay, please try these three by yourself. Okay. Okay, this example 9 is same as a previous one, so try to work on that. Okay, give me a second. I think if it's better if I mention at least these two. Okay, I'll do this one as well. YOZ, YOC, Y and C. Okay, this one. YOC mean everything everything includes to X and C and Y. Okay, so you can simply check these two, C and Y, and write down them. EDV, you don't need to write again and again. Okay, don't write repeated outcomes, just write down it once. EDV, then EDL, then EDA. Check this one. We have EDV, we have EDL, we have we don't have EVL. What is this? EA, what is this one? ELA, EVL, EVA. This should be EVA, right? EVA, we don't have EVA, and ELA, DVL, and VLA. I'm so sorry about my handwritings. Please, I think you can understand this. I think you can at least read this. Okay, so check these values: EDV, EDL, EDA, EDV, Again EDV is there, EDL is there, EVL, EVA, ELA, DVL and VLA. Okay, these are the Y O Z. So like this, try to do this example. Okay, now I'm going to explain something like uh, the relationship of events. Relationship of events we call a mutually exclusive event, which mean two or more events are two or more events, if they don't have any connection, we call they are mutually exclusive events, which mean two or more events, they are mutually exclusive event if no two of them have outcomes in common, which means simply mutually exclusive, they don't have something like this. Clear? They don't have something like this. If you consider two events, they don't have something like this. Okay, mutually exclusive, they don't have outcomes in common. This is the common case. Okay, this is the common area. If events are mutually exclusive, they don't have a common area or common outcomes. Okay, see this one, two mutually exclusive event, they don't have a common area, but here it has a common area, which mean non mutually exclusive. Okay, same as this, you can extend this up to any number of events. So you can see this is all mutually exclusive, this is not mutually exclusive, and this is also not all mutually exclusive. Okay, CA or CB mutually exclusive, but all three are not mutually exclusive. Okay, let's try to do this one. This example again, we are trying to deal with some kind of problems. Okay, we are trying to deal with problems by using these probability techniques. So let's check this one. Playing card, a deck of cards contain 52 cards. Okay, you know that we will be having to have 52 cards, including picture cards and non-picture cards. Okay, so if you consider a deck of playing cards, you will be having 52 cards. These are the all possible outcomes. All possible outcomes. Clear? Okay. Now what? Playing cards. For the experiment of randomly selected one card from deck. Okay, I am going to select one card. A event. A mean event, the card selected is King of Hearts. Okay. B is card selecting is a king, just king. This is King of Hearts, this is just king. C event, the card selected is heart. Okay. D is card selected is a face card. Face card mean picture card. Okay, face card mean picture card. Now we need to find the outcomes of not D. Okay, first not D. What is D? Not D. Not D mean face card, right? Not face card. Okay, I need to find not face card. What are the face cards? These are the face cards, right? See, these are the face cards. Not D. D is the face card. So this is D. This is even D. So not D is this. This is the not D, right? Easy, right? Okay. B and C. B and C. Oh, sorry. What is B? Selecting is a king. C is heart. So B and C mean king heart, right? So B should be the king. C should be a heart. So both together and, which mean king of heart. So where's the king of heart? See this one. So this is the B and C. B and C. Clear? This is really fun. So you can try C. I'll do D. Okay. What does this mean? C and D. What is C? Heart. D is a face card. D is a face card and C is a heart. So this means face card, heart. Face card, heart. It should be a face card, but definitely at the same time it should be a face card. So these are the face cards, hearts. This one, right? So this one becomes C and D. Okay. I think you can get a rough idea. So please try to do this example again. There is another example based on how US census. So these are the room numbers. How many rooms? 1 to 8 to 8 plus. There is a number of units for each rooms. So using this, they have asked few questions. This is exactly same as the previous case. You have to identify what is the outcome, okay, for according to each situation. So please try to do this example. Okay. So I hope that you guys get an idea about how we use this probability, or how we measure these kind of probabilities in general. Okay, there are so many advanced techniques, but this is the easiest and simplest technique. So I hope you enjoy this video. So I will continue this video in this section in next video. Okay, so have a nice day and stay safe. Thank you very much.